Nissan e-Power reliability, the 2026 Nissan Qashqai e-Power, and the mechanical engineering behind the latest Nissan X-Trail are the only things people are talking about in the 2026 auto market right now. But there is a brutal truth about this fake EV technology that the marketing teams are absolutely desperate to keep hidden from the average buyer. Nissan is spending hundreds of millions of dollars globally to convince you that e-Power is the ultimate bridge between the old world of internal combustion and the new world of electric vehicles, calling it an EV experience without the plug. But as a gearhead who looks at torque curves and energy conversion losses instead of glossy brochures, I see a system that is a masterclass in unnecessary complexity. If you've been looking at a new Nissan and wondering how it can possibly offer the silence and smoothness of a Tesla while still taking regular unleaded at the pump, your mechanical instinct is right to be suspicious. By the time we get through this, you will understand the massive engineering trade-offs Nissan made to create this series hybrid. You will uncover the efficiency lie that makes e-Power a terrible choice for long-distance highway drivers, and I'm going to reveal a specific component in this drivetrain that is already starting to show catastrophic failure at just 60,000 miles, a repair so expensive it wipes out every cent you'll save on fuel over the life of the car. If you want car content that treats you like an adult with a brain and a budget to protect rather than just another target for the dealership's next quarterly bonus, take a second to hit that subscribe button, tap the notification bell, and join a community that values mechanical durability over marketing hype. To understand why I call this fake EV technology, you first have to understand what is actually happening under the hood of a 2026 Nissan e-Power vehicle compared to a traditional hybrid from Toyota or Honda. In a standard hybrid, the gasoline engine and the electric motor are both physically connected to the wheels, meaning they can work together or independently to move the car forward. Nissan's e-Power is what engineers call a series hybrid, which means the gasoline engine has absolutely no mechanical connection to the wheels whatsoever. It is essentially a rolling power plant. The 1.5-liter engine under the hood exists for one reason and one reason only, which is to run a generator that sends electricity to a small battery, which then powers an electric motor that actually turns the tires. Nissan markets this as a pure EV drive feeling, and while they aren't lying about the smooth acceleration and instant torque, they are conveniently ignoring the massive energy conversion losses that happen every single time you turn a drop of gasoline into motion. In a standard car, you go from chemical energy to mechanical energy. In a Nissan e-Power, you go from chemical energy to mechanical energy, then to electrical energy, then to chemical energy in the battery, then back to electrical energy, and finally back to mechanical energy at the wheels. Every one of those steps generates heat, and in the world of engineering, heat is the ultimate enemy of both efficiency and long-term reliability. The industry is counting on your ignorance right now, and the version of you that exists 5 years from now is already mourning the thousands of dollars you're about to lose because you didn't see the trap coming today. I've spent my life documenting the mechanical cheat codes that dealerships hope you never find, and I've put them all in a single place so you can stop being the victim of these high-tech scams. Check the pinned comment before it is too late for your wallet, because once you see how they actually manipulate these repair cycles, you'll never look at a dealership the same way again. The first major lie about Nissan e-Power in the 2026 market is the idea that it is as efficient as a real hybrid in every driving scenario. If you are driving in heavy stop-and-go traffic in London, Tokyo, or New York, the e-Power system is actually quite brilliant because electric motors are incredibly efficient at low speeds where internal combustion engines struggle. But the moment you take a 2026 Nissan X-Trail e-Power out on the open highway at 70 or 80 miles per hour, which is exactly where families spend their vacation time and road trips, the efficiency falls off a cliff. At highway speeds, a traditional Toyota parallel hybrid can lock the engine directly to the wheels for maximum efficiency, bypassing the electrical system entirely. The Nissan, however, still has to go through that entire chain of energy conversion. The engine has to rev high just to keep up with the electrical demand of the motor, and you end up burning more fuel than you would in a simple non-hybrid gasoline car. I have seen real-world testing where e-Power vehicles struggle to hit even 35 miles per gallon on long highway hauls. You're carrying around the weight of a battery, an inverter, and a complex gasoline engine, yet you're getting worse highway mileage than a 20-year-old Corolla. This is the definition of fake EV technology because it gives you the quiet hum of an electric car while still tethering you to the gas pump at a higher cost per mile than the competition. The mechanical controversy goes even deeper when you look at the specific engine Nissan chose to use as the generator, the 1.5-liter VC turbo. This is a variable compression engine, which is one of the most complex internal combustion designs ever mass-produced in history. It uses a unique multi-link system to physically change the stroke of the pistons and the compression ratio of the engine on the fly, depending on whether the car needs power or efficiency. While this is an engineering marvel, it is a reliability nightmare for a long-term owner. In a standard hybrid, you want a simple, under-stressed engine that can handle the constant stop-start cycles without drama. Nissan instead gave you an engine with dozens of extra moving parts, bearings, and actuators inside the crankcase. We are already seeing reports from the 2026 market of these VC turbo engines developing bottom-end issues and complex oiling problems as they age. When you combine an unproven, highly complex variable compression engine with a high-voltage electrical system, you aren't getting the best of both worlds. You are getting a double-layered risk profile. If that variable compression linkage fails at 100,000 miles, you aren't just replacing a sensor, you are likely replacing the entire engine block, and that is a bill that will make a battery replacement look like pocket change. Let's talk about the psychological trap Nissan is setting for the 2026 buyer, because this is where the marketing is truly clever. When you test drive an e-Power Qashqai, you are immediately seduced by the silence and the linear power delivery. It feels premium, it feels futuristic, and it feels like you found a loophole in the car market. But this is digital seduction at its finest. Nissan is banking on the fact that you won't look at the maintenance schedule or the long-term complexity of the inverter cooling system. Because the engine is acting solely as a generator, it often runs at a constant high RPM that sounds completely disconnected from how fast the car is actually going, which creates a strange, disconnected droning effect. More importantly, because the engine is constantly cycling on and off to maintain the battery buffer, it experiences massive thermal cycling that is brutal on seals, gaskets, and turbochargers. For a father trying to buy a car that will last 15 years, the e-Power system represents undefined risk. We have decades of data on how a Toyota or Honda behaves. We have almost no data on how a variable compression series hybrid will behave after 10 years of school runs and family road trips in extreme weather.
There is also the massive issue of weight and suspension wear that no one talks about. The e-Power system adds significant weight to the front end of the vehicle compared to a standard gas model. In the 2026 Nissan lineup, we are seeing the same pattern as with other heavy hybrids, which is premature wear on front struts, control arm bushings, and tires. If you aren't prepared to replace your front tires every 15,000 miles, the e-Power savings start to look even more like a myth. And because the braking system is a complex blend of regenerative braking and traditional hydraulics, the brake-by-wire feel can be inconsistent and incredibly expensive to calibrate if a sensor fails out of warranty. Nissan is selling you a simplified EV driving experience, but they have built it on top of a mountain of mechanical and electronic complexity that requires specialized dealership tools just to diagnose a simple fault. You are effectively being locked into the Nissan dealership ecosystem for the life of the vehicle, which is exactly where they want you. This debate is playing out globally in very different ways. In Europe, where diesel is being taxed out of existence, e-Power is being sold as the logical, clean replacement. But in Australia and the Middle East, where reliability in extreme heat is the only metric that matters, the skepticism is high. A series hybrid generates a massive amount of heat in the inverter and the battery during heavy use. If you are climbing a long grade in 40-degree heat, the thermal management system in an e-Power Nissan is working overtime just to keep the electronics from throttling back the power. If the car goes into turtle mode because the battery is hot and the generator can't keep up with the cooling demand, you are left with a very expensive, very heavy vehicle that can barely pull itself out of its own way. This is why you don't see e-power being used in serious off-road or heavy towing applications, because the engineering simply isn't robust enough for real sustained work. It is a city car dressed up in an SUV body, and that is a distinction that matters more than most people realize. The fake EV label also applies to the environmental marketing that surrounds these cars. Nissan wants you to feel like you're doing your part for the planet, but because of the energy conversion losses I mentioned earlier, the total carbon footprint of an e-power vehicle over its lifetime is often higher than a simple lightweight gasoline car or a more efficient parallel hybrid. You are paying a premium for the feeling of being green without the actual benefit. It is a brilliant bit of corporate positioning, but it doesn't hold up to the physics. If you genuinely want to save the planet and your wallet, you either buy a lightweight, fuel-efficient gas car, or you go for a full electric vehicle with a massive battery. The middle ground of e-power is a compromise that serves the manufacturer's emissions credits far more than it serves the consumer's needs or long-term financial health. I want to hear from you in the comments below. Do you think Nissan's e-power is a genuine innovation that offers the best driving experience on the market, or is it just a clever way to keep the internal combustion engine on life support by wrapping it in an electric cloak? Are you an owner who has seen the real-world highway mileage, or are you a mechanic who has already had to deal with the complexity of the VC turbo engine and the e-power inverter? Let's get a real argument going, because the more we share the truth, the less power these marketing deceptions have over our lives and our savings. We need to hold these companies accountable for the engineering they put in our driveways, and that starts with asking the hard questions that the salespeople can't answer. Now, I want to talk about that specific failure point I mentioned earlier, the one that is already starting to show up at the 60,000-mile mark. That component is the high-voltage inverter and its dedicated electric cooling pump. Because the e-power system relies entirely on the inverter to convert the generator's AC power to DC for the battery and then back to AC for the motor, that inverter is under constant high amperage stress every second the car is in motion. We are seeing early failures where the internal capacitors or the cooling pump itself fails, and because this is a sealed, proprietary Nissan unit, you cannot simply fix a part of it. You have to replace the entire assembly, and in many regions, that cost is upwards of $6,000, including labor. If you saved $20 a week on gas over 60,000 miles, you have saved about $5,000 in total fuel costs, which means the moment that inverter fails out of warranty, you are officially in the red. You have paid a premium for the car, paid for the extra maintenance of a turbocharged engine, and still ended up with a repair bill that wipes out every single benefit of the technology. If you want to stop being a victim of these engineering traps, you need to understand the difference between a car that is built to last and a car that is built to sell. Dealerships are banking on you not knowing the difference, and that is why knowledge is your only real defense. Don't let your next car purchase be the reason you go broke or lose your peace of mind. Check the link in the pinned comment, protect your wallet, and start seeing through the fake EV marketing that is flooding the 2026 market. If you appreciate this kind of veteran, fact-driven analysis that refuses to bow to corporate sponsors or dealership pressure, hit that subscribe button, turn on your notifications so you never miss a deep dive. This is Gearhead Genius, and remember, every car has a story, but only the owners know the truth. See you in the next one.